Now we're going to be looking at the normal distribution for the rest of the chapter. Hopefully you've spent some time looking at the previous slides that talked about standard normal versus non-standard normal, and also about how to find boundaries when things are greater than, less than, or in between. So we're going to work through some examples, and this first one says, if z is a standard normal variable, find the probability that z is less than negative 1.76. As you study these problems, sometimes they'll be written out in words, sometimes they'll be written out in symbols. So we've put here the probability, P, parentheses, z is less than negative 1.76. Hopefully you're good with your less than and greater than symbols. And we also want to remind you that when it says find the probability, remember it's also like finding the area, because we're going to look under the curve and it's going to represent the area of that value. So if we look on our normal curve here, and we've drawn these out for you, but we hope that you will draw your own, especially as you're learning and practicing with the homework. And so you can see that 0 is in the middle of our x-axis, horizontal axis, but it's no longer an x because these are representing z-scores because it's standard normal. And simply by using the word standard up in the problem, we know that mu, mean, is 0, and standard deviation, sigma, is 1. And so you can see that the chart has been labeled with a 0 in the middle, and then 1, 2, 3 labeled to the right, and negative 1, negative 2, negative 3 labeled to the left. However, what if the numbers were going further than 3? Well, according to the slides you already had, we're going to go all the way up to positive 9999. Now, obviously, that's a big jump, but I just want you to be reminded that the positive numbers are going off to the right. Same thing with to all the way to the left. Below negative 3, we're going to go all the way down to negative 9999. So we're never going to use both sets of nines. It'll depend on which way we're shading and which way we're looking. In this problem, it says negative 1.76 is the value. So we're going to estimate that between negative 1 and negative 2, put a dot, and then draw up to where it hits the curve. And less than, of course, means to the left. So we're going to shade underneath the normal curve to the left. And it doesn't just go to the negative 3. It goes past it, past it, past it. Where does it stop? At the negative 999. So how do we calculate it? Well, you can actually do some calculus, or we can use our wonderful graphing calculators. Hopefully you've got yours with you. And if you looked at the slide with the keystrokes, you know that if you do second and the button that says vars up above it, it says distribution, which is actually what we're using. We're going to use number 2. We're never going to use number 1, the normal PDF. We're always going to use number 2, the normal CDF. So you can either arrow down or just hit the number 2. And if you have the new operating system like is on your screen, then you can see the 4 things we're going to have to type in: the lower, the upper, the mu, and the sigma. And you can see that they already have a default for the lower, which is negative 1 e, which is just the exponent, like to the power of 10 to the 99th. It's actually scientific notation. We're going to change that, but what are we going to change it to? So let's go back to our slide. If we're going to use normal CDF, we're going to write out normal CDF, and your teacher is going to want you to write what you type so that you can, that's kind of your way of showing your work. And then I'm going to put parentheses, and let's write for this first example, lower, comma, upper, comma, mu, comma, sigma. If you have the old OS, unfortunately, it doesn't ask you for those 4 things, so you have to remember to always type them in that order, and so we'll write them every time in that order as well. So for our normal CDF, what is our lower value? And remember, they're talking about the shaded area back under the curve, and lower is just going to be left. So the most left value, the lowest value, were the negative 9s, negative 9999, comma. And then what was the upper value? Well, that was the dot we labeled negative 1.76, which came from our problem. And so it's kind of like saying the left side and the right side of your shaded value. The left side is lower, the right side is upper. And then our mu is 0, our sigma is 1. And so we go back to type that into the calculator. Again, if you have the old OS, you're just going to type it exactly the way we wrote it with commas in between. If you have the new OS, we're going to replace that lower boundary with the negative. Make sure you hit the negative, 9999. And then you can arrow down or hit the enter down. And so we'll do negative 1.76. The mu is already defaulted at 0 and 1 for sigma. That will change in later problems, but for right now it's good. Arrow down to where paste is highlighted and press enter. And you'll notice that we are seeing the end of the problem like what we just typed or what we just wrote on our slide. So press enter again and we get our answer. Almost all of these probabilities will be rounded to 4 decimal places. So 0.0392, no rounding there, gives us our decimal. And I want to point out, we mentioned it earlier, that the whole graph, in this case it's not a rectangle, but the whole normal curve equals an area of 1. So if you've only shaded a tiny bit, then you should have a tiny area. The more you shade, the closer your area will be to 1. Let's do another question. This one says a certain set of Celsius thermometers have a mean reading of 0 degrees and a standard deviation of 1 degree for freezing water, and thus is described by the standard normal distribution. For a randomly selected thermometer, find the probability that the reading is between -2 and 1.5 degrees. So a couple of things to make sure that you look at. Because it said standard, I underlined standard, we automatically know, plus it told us, that mu, mean, is 0, and sigma, standard deviation, is 1. It also is asking us to find the probability, so we wrote that out in symbols. P, parentheses, -2 is less than Z is less than 1.5. But, again, I want to remind you that we're finding the area. So let's shade it. We've got the normal curve on your screen. Again, 0 is already in the middle. And even if you don't choose to label anything else on your graph, you want to always start with the 0, the mean, in the middle. And then -2, of course, would be to the left. Positive 1.5 would be to the right. Go up to the graph on both of those dots and then literally shade between. We love the between ones. It's really obvious. Now, are we going to need the 9s in this case? Think about where the -999 is, all the way to the left. Think about where the positive 999 is, all the way to the right. Our shaded area doesn't go to either of those numbers. So, as we prepare to type in normal CDF, again, always write it down before you type so that you can get in the habit of showing your work. Our lower boundary is just the -2 that they gave us, comma. Our upper boundary is the 1.5 that they gave us. So we didn't need the 9s in either of these situations. And then mu stays 0, sigma stays 1. Let's type it into our calculator. Second vars, or distribution, number 2. Remember that, of course, you're just going to type over it. So we have the -2, arrow down, 1.5, arrow down, and then the Z and in the 0 and the 1 are already there as defaults. So you can press enter or arrow, paste, press enter one more time, and we have 0.9104. 0.9104. And again, notice that number is really close to 1. And how much of the graph did we shade? Almost the whole graph. And so again, little graph, little decimal, not close to 1. Big shaded graph, then you should have a decimal that's close to 1.